Let's see log track now. So it's similar to the dam track. I will select the tank and we'll select ball as the target. So right now the logged axis is z axis, and if I move the ball, the tank will only rotate in z axis. As you can see, if I move the ball, the tank is only limited to the z axis. It will only rotate in z axis. Let's change the axis to x axis, and the moment I do that, it will only rotate in x axis, as you can see. So now we have basically logged it. Now see, it is not moving in z axis, it is only moving in x axis. Let's apply limit distance. We'll choose the target as monkey and we'll choose the distance as 5 meter. So basically what it does is, there will be a sphere, invisible sphere of 5 meter. So if I draw a sphere, let's say, let me annotate it. So I'm drawing this sphere of 5 meter. This is the distance and this is in 3D. So this ball cannot escape this, okay? And so because I have put it inside, if I put it outside, so this ball is now outside, but it cannot enter the sphere of 5 meter, that invisible sphere of 5 meter. You can create a lot of animation using this. So like, you know, a missile is coming on the home and it is unable to penetrate, this sort of thing. There is also option of on surface. So on surface is very simple. This ball basically will rotate on the surface of this invisible sphere that we were talking about. Let's see the example of copy location. I have selected this gate and I have applied copy location. Now I have put influence as 0.5 and I am just giving x-axis. So target is the first gate. So if I am moving the first gate, the second gate will basically overlap at some point, because let's say the speed of first gate is 10, then the speed of second gate will be 5. So this is what influence will do. If we change the influence to 0.2, the second gate will come even more slower, it will move even more slower. So this is the meaning of influence. Limit scale means limiting the scale value of any object. So right now let's put z minimum as 0 and z maximum as 4 meter. So if we increase or if we scale this cylinder, it will only increase in z axis, and that too only till 4 meter. So I can try anything, but it will not increase in other axes. So this is the constraint, which means limiting the scale. Let's add the value of y also. So in the y minimum we'll put 0 and y maximum will put 2, this time not 4 but 2. So now if we scale, you can see this sort of effect where it is scaling in 2 axes, but it is limited by the number we have put here, the 2 and 4 meters. So as the name suggests, limit rotation means we are going to limiting the rotation. We'll apply limit rotation and let's apply on the z axis. So we'll select this, put z axis, minimum we'll put minus 90 degree. So we'll put a rotation of 90 degree and maximum will be 0. Now if you rotate it, you can see it is not crossing more than 90 degrees. So like a door, it's basically just rotating 90 degrees within the z axis. Same goes for x and y axis, so you can play around it. Let's see dam track constraint now. So it's very easy. Select the tank and under tracking select dam track, choose the target as this ball. So now if I select the ball and if I move it, so my tank is basically logged to that. So let's consider this ball as a bird. So if I just move this bird, the tank nozzle will follow it. So you can use it in your animations for, you know, bow and arrow kind of, or war zone kind of situation. Basically you can make one object follow the other object. Let's see pivot constraint now. So as you can see, if I rotate, the origin is at the 3D cursor, but I want to make it switch the origin point. So I'll add an empty axis, any empty axis, and I'll just move it around here. Let's add the constraint, pivot constraint, and as you can see, we can choose the target as our empty axis. And now if I try to rotate it, look at very closely. If I try to rotate it, it will switch to the origin. So basically from one origin to other origin it will switch, and it will have like this sort of wobbly effect, like how monkeys hang from one tree to other tree. So to animate this, we can use this constraint. Track to basically will track the object. So let's select the camera, add the track to, and select target as monkey. Let me split this screen so that you will see it much more clearly. Now no matter where I move the monkey, the camera will follow the monkey. As you can see in the left hand side of the screen, this is like kind of a you might have seen in the car chase sort of in the movies. So this is how it is used. Basically it is used with the cameras, this particular constraint, but you can use it in any form. Like you can also use for the two objects. We have basic settings, influence and everything, but the basic idea you must have understood. Let's apply maintain volume now. So maintain volume will have three axes, x, y, z, and we can put the value of volume. So for example here I have put 2 meters. So if I tend to scale it, it will scale but it will maintain the volume. So it will maintain the scale but it won't lose the volume of the object. This is used in dynamic animation. So as you can see, this UV sphere itself has converted itself into a sponge ball sort of thing. So maintain volume is used in such animations. Next we'll see is copy scale. So we'll apply copy scale and we have three axes here. We'll choose the target as other cube. Now if I increase the size of one cube, all the three axes will increase of the other cube. And let's say if I choose only x-axis, then the other cube will only increase in x-axis, not in other two axes, y and z. We can also change the power to -1, which means if I increase the size of cube, the other cube will decrease in size. So it is kind of inverse, like what we have seen before. But you can give any number to the power. So it could be 2, 5, 10, -2, -5, -10, like this. Select the icosphere and apply copy location constraint. So we have axes here. We'll choose the target as monkey and we have chosen the axis as x-axis. So if we move the monkey in x-axis, our icosphere will move. But if we choose the monkey in other axes, let's say in z-axis, it won't move. So basically it is limited to the axis. So in x-axis it will move, in other axes it won't move. For example, if we change the axis to let's say z-axis, so now if I move the monkey in z-axis, it will move, the icosphere will move, but if I move it in x, it won't move. Now there is an option of invert. If we put invert, so you can see what invert can do. If I move monkey in plus x, the icosphere will go in minus x. If I do all the three axes, it won't make sense because basically it will overlap, both the objects will overlap on each other. We can change the influence to reduce the amount of change in the motion or change in the constraint. Now if I check the offset, so basically what it does is if I move the monkey little bit downwards in z direction and if I move it let's say in x-axis, then the icosphere will also move, so it won't have any effect. So offset means we can give offset between the objects. Let's see the child of constraint. So we'll select blue cube and put target. Target means the father. So this green one is the father, blue one is the children. Now we have option of location, rotation and scale. So generally if I scale the father, the child will also rotate or scale or do whatever. But we have option to edit it. So you can see in the rotation or location, if I just switch off all the location and if I just put in the rotation, if I rotate the father, child will also rotate. But if I move the father in x-axis, the child will not rotate. So we have basically rotation constraint. So now let's say for the location, if I put location in x-axis, if I move the father in z-axis, the child won't follow. But if I move the father in x-axis, the child will follow. So basically whatever the target does, the child will follow. Remember that we always have the option to choose the axis. So you don't need to switch on all the axes. You can choose any one. So in this case, if I do scale the father, the child will only scale in z axis. So this is the constraint. This is the power of this constraint. We can play with the influence as well. We have one more option of inverse. So if I increase the father, the child will decrease, and if I decrease the father, child will increase. So we can do that in rotation and location as well. So just play with this example. You can do a lot of things. Next is copy transform. Copy transform is the combination of all the three that we have seen before. So it is also similar to the parent one. So if we can give the target as this monkey, so like we do parenting in the modeling, this is the similar one. If I increase the monkey head, the other one will also increase. If I rotate, the other one will rotate. So basically this is parenting. But you can think it as a copy transform constraint, which is a combination of copy rotation, copy location, and copy scale. This is similar to copy location. We'll apply copy rotation this time. We have similar setting, but let's say now we'll rotate it in y-axis. We'll choose the target as other gear. Now if we rotate, you can see both the gears are rotating in same direction, but generally this does not happen, so we need to apply invert in this. Now watch very closely. I am moving this gear, but the other gear is not moving. I put this because I want to show you both the axes should be on in order to make it rotate. So now if I move, see, so one gear is rotating in one direction and other in other direction. So this is much more intuitive and much more realistic. We have seen influence last time, so let's see influence this time also. Basically the speed of one gear will be reduced, and now if I rotate the first gear will rotate in a much more speed than the second one. Let's see floor constraint. So now we'll select the monkey and add floor constraint. We'll add the target to cube. Basically this monkey is now constrained with respect to the cube. So if we select the z-axis in the maximum minimum, it will only move in the z-axis and not in any other axis. If we do it minus z, it will go down in the z direction like this. If we do x-axis, then this monkey will only move in x-axis, not in any other axis. So this constraint basically restricts you to the motion. It's like tying you with a rope and you can only move in certain direction. So if you want to move in certain direction and you want to rotate, then you have to check this use rotation. So now you have freedom to rotate, but you will still be restricted to the motion. Basically you will be given a particular axis on which you can go and move around and rotate. Let's say limit distance. So basically limit distance means I don't want this door to cross over the other door. I want it to stop on the second door. So I'm going to apply the constraint on the left door. So we have to put the value of minimum x and maximum x. So press N to get the value of x. So as you press N, we have this x. Copy this value and just move this door again back to the right side. And on the left door, we'll apply the constraint. We'll put minimum value, we'll paste it, and the maximum value will be 0. Now if you move the right door, it will cross over the left door because we did not apply the constraint on the right one, but we have applied constraint on the left one, and as you can see, the left door is unable to cross the right door. So it will give an effect of closing the door, overlapping one upon another. So this is limit location constraint. So next up is transformation. So I have this gear here and I have this empty cube. You can add it by going to add empty and empty cube. Let's apply the transformation constraint and put target as empty box. Now we have two options here, map from and map to. Map from means whatever we change in the cube, the empty cube, we'll put all the values here. So let's say in y maximum I'm putting 10 meters, and map to means this gear. Map to, I'll put y max as 10 meters. So now if you move this empty cube, the gear will follow. Pretty easy, pretty simple. But let's say we want to change the transformation. Let's change it to x-axis. And now if I move, nothing is happening. Why? Because the source axis is changed now. So source axis of the cube was x-axis, so we have to put source axis as y-axis. And now if I move in y-axis, the gear will move in x-axis. So basically transformation constraint means we can give one motion to first object and the second object will do a different motion, and we can link both of them together. And now I have changed the location in z-axis, so as the cube is moving in y, gear is moving in z-axis. Let's see rotation now. So we'll apply the transformation constraint. Let's put y max to 10 for the cube, and this time we are going to map to the rotation. So source will be y this time because the cube is in y axis, and we'll put maximum as 360 degree. So, and this is the order that you need to change for rotation. We'll put y, x and z. So if we move this cube, you can see the gear is moving in the opposite direction. So this is very useful animation we can use. The movement of cube will basically change the rotation in the gear or in any object for that matter. So just apply the constraint, play with the settings, come up with different ideas and apply all the constraint. That way you will learn more faster. So last time we saw transformation in location, but this time we'll see transformation in scale. So we have three options: location, rotation, scale. I'm not doing any changes in the cube's value, but you can change it. Or I'm only changing the gear value. So as you can see, if I move the cube, the gear will increase its size to a limit that which we have put. Similarly, we can change the value of the gear again, and now this time if I move the cube, it will increase the scale in x-axis. The only thing that you need to remember is the source axis. Rest everything is pretty straightforward. Now let's see stretch to. So select the object, go to stretch to and choose the target as this arrow. Basically, if there are option of rotation and maintain volume. Basically, if I move the arrow, this block will change its shape. It will also rotate and it can basically change its shape. So there will be like two motion. One motion will be of the arrow that is coming towards it, and the second motion will be changing the shape of this block, red block. So now as you can see, if I move the arrow towards this block, it is stretching itself and compressing itself. Okay, so because we have changed the maintain volume option, now if I put it in Z direction, then it will stretch itself in Z direction, and we have option of x-axis, so it will stretch in x-axis. So basically two objects will change depending upon the location. If you increase the volume variation here from 1 to let's say 3, so now the block will adjust itself in the volume, which means it will have a limit of the stretching. It can't endlessly stretch. First of all, we'll need a short animation of door opening. So what we can do is, from 0 to 50 frame, we are going to create an animation. We'll go to action editor this time, and we are going to save the animation as door open here in the action editor. Next thing is press Ctrl A and choose location to both the door and the lever, and if you press N, you'll see the location is 0, 0, 0. Select the door, apply action constraint and target as the lever. So if you move lever upwards in Z direction, we should be able to pull off the animation. So in the maximum we are going to put 1.8 because the distance is 1.8 in Z location. Under the action, choose door open animation, and frame is 0 to 50 because the animation was from 0 to 50. Now if you pull the lever upwards, it will play the animation, and we can actually control the animation from the outside object. So this is the power of this constraint, this action constraint. We can control the animation through an outside object just like this. So if we pull the lever, the animation will play of door open. Now we'll see shrink wrap constraint. So select the ball and apply shrink wrap and choose the target as plane. So now you can change the distance. Basically this distance is distance from the plane of the ball. We'll put it at 0.1. There are few more mods available, but let's start with the normal one and the nearest surface one. We can choose to apply to the normals and the axis, but let's leave it for now. Let me tell you what it does. So as I can move the ball, it is basically just moving on top of the plane. So like we had shrink wrap modifier, but the modifier does not allow us to move the ball like this. So in this particular case, we can move this ball on the top of this plane. Now this plane can have anything like the mountains and any sort of geometry. This constraint is widely used for animation. Let's see few of the snap mode. Now this is outside. So outside and near surface and on the surface are almost similar. And as you can see, the moment I move the ball in this direction, it is basically jumping on this small mountain sort of thing. Basically this is all this constraint is. You can just move any object on top of the surface of any object. Very useful for animation, so play with this constraint. Make different sort of planes, use landscape, ANT landscape, and try to move the ball or any object on top of it. We will see clamp to constraint. We have a small car object and a curve here. So we'll select the car and we'll go to constraint and we'll select clamp to under the tracking. So in the target, we'll put target as our curve. So now basically what it will do is, if I have 3 axes here, but if I can put it on auto, and we have influence as always. So if I move the car, if I select the car and if I move it, it will follow the curve. So clamp to, by the name as it suggests, if I move it, it will follow the, and it's not just limited to this car. Any object, if you wanted to make it follow any curve, once you move it, then clamp to is the constraint that we can use. If you check the cyclic option, basically what it says is it will follow the check. If you move the car, it will just follow the curve in a cyclic motion, so it won't stop at the end.